Hello folks, today we're going to be going over the tens. The front page is a review from yesterday. I would encourage you to do it. It's a nice review, lets you know if you do know what you're doing. I have some answers on the previous slides, but I'm not going to go over these because it is review. But I would encourage you to check your answers, try things, pause it, see how you do on it. We're going to go on to the back side, and we are going to start with these rules. Rules for oxidation numbers. So free elements means any element on the periodic table, and diatomics, so it'd be like Br2H2O2, all those are diatomics. Free elements would be just like Fe. They all have an oxidation number of 0. This is on the cover of your unit pack. We also used this information yesterday. The rules that we're going to institute right now, though, is that an H in a compound is always going to have a positive 1 charge, and an O in a compound is always going to have a 2 negative charge, and that's going to allow us to do some math. So in this problem, manganese would have a 2 positive, zinc would have a 2 positive, zinc ions would have a 2 positive, and our zinc metal will be 0. But now our goal is to figure out what are the oxidation numbers in this problem. So what we just learned on the last slide is oxygen's going to have a 2 negative, but there's 4 of those oxygens, so if we do the math on that, that's 8 negative. That 8 negative that I wrote there is nothing to do with the problem, it's just a way of keeping track of the math. So right now I have 8 negative, negative 8 plus something equaling 1 negative, because the charge on this molecule is a 1 negative. So what plus 8 negative equals 1 negative? Well, that's a 7 positive, and that's how we get the oxidation number for manganese. So that's what we're going to learn in this setup. So here we go. Oxygen, an O, is always going to be a 2 negative. And a hydrogen is always going to be a 1 positive. So I look at this problem, I put a 2 negative there, and I have 2 of them, so that's a 4 negative. So the whole thing's going to add up to 0 because there's no overall charge on sulfur dioxide, so this sulfur must be a 4 positive. So sulfur is a 4 positive, and oxygen is a 2 negative. We go over to this other problem. Again, oxygen's a 2 negative, and then nitrogen, since there's no overall charge on NO, nitrogen would have to be a 2 positive. Try to do this problem on your own. I will go through all of them, but pause the video, see if you can do it on your own before you watch the video. So in this one, we have SO2. We got a 2 minus up there. So our oxygen's a 2 minus. There's 2 of them, so it's 4 minus. So we have 4 minus plus something equals 2 negative, because again, the overall charge there is a 2 negative. So the answer in this case would be a 2. So sulfur is a 2. So oxygen's a 2 negative, and sulfur is a 2 positive. We go over to the other problem. We have a 2 negative for oxygen. There's no overall charge on N2O, so the whole thing's got to add up to 0, so each nitrogen must be a 1 positive. Again, try the problem to make sure that you know what you're doing. Pause it, then watch me. Well, sulfur is found on the periodic table, and that is found in its neutral and normal state, so its oxidation number is 0. NO2, 2 negative, and there's 2 of them, so that's 4 negative. So the nitrogen must be a 4 positive. Again, you should be pausing the video and trying these before I show you the answers. S2O3, the overall charge is 0. 2 negative there. There's 3 of them, so that's 6 negative. So all of this over here has got to be equal to 6 positive. I have 2 sulfur, so I take that 6 divided by 2, and I get that each sulfur is a 3 positive. Overall charge is 0. 2 negative. There's 4 of them, so it's 8 negative. So this nitrogen must be an 8 positive, but there's 2 of them, so 8 divided by 2 is 4 positive. So we're seeing here that the nitrogens are changing and the sulfurs are changing, and that is what happens on the periodic table. F2 is one of those diatomic gases. That's how it's found on the periodic table, so its oxidation number would be 0. N2 is one of those diatomic gases. That's how it's found on the periodic table, so its oxidation number would be 0. This one's a little tricky because there's no hydrogen, there's no oxygen to figure out. So when all else fails, you use the charges off the periodic table. So bromine's a 1 negative and lithium's a 1 positive. Both of those are the charges off the periodic table, and they seem to work. So that's a 1 positive and that's a 1 negative. H3PO4. Okay, so we got H3PO4. So our oxygen's a 2 negative, and there's 4 of them, so that's an 8 negative. There's each hydrogen's a 1 positive, and there's 3 of them, so that's a 3 positive. So right now for our math, we have 3 plus something minus 8 equals 0. Well, the math here says that this has to be a 5, so that means our phosphorus is a 5. So I put a 1 positive, 5 positive, and a 2 negative. H2SO4. Again, hopefully you are pausing the video and trying all of these yourself. 2 negative, but there's 4 of them, so it's 8 negative. Hydrogen's a 1 positive, but there's 2 of them, so it's a 2 positive. So 2 plus something minus 8 equals 0. Well, my brain says that this is a 6. So it's a 6 positive. O2, that's how you find it off the periodic table. That's how it's found in its normal state. Oxidation number of 0. All right, so those are done. The next page is your homework. It's slightly more complicated because we first give you either the formula or the name, and you have to go from there. Come on in if you need more assistance.